Hi, this is Professor V.K. Patil. I welcome you to my video classes on basic electronics. In my last class, we have discussed about the two transistor model of silicon controlled rectifier. Also, we have derived the expression for the anode current. Today, we will see the phase control of SCR. What do you mean by the phase of a SCR? The phase of a SCR is also known as the firing angle of an SCR. What do you mean by the firing angle? It is the instant at which the SCR it turns on. That is nothing but the firing angle of a SCR. We know that SCR is a control device and its conduction, that is turn on, it can be controlled by using this phase or the firing angle. We know that the anode current IA it can be given as alpha 2 into Ig plus ICBO1 plus ICBO2 divided by 1 minus alpha 1 plus alpha. This is what we have discussed in last class. Now if you observe carefully this expression, simply by increasing the value of Ig, I can increase the value of I. Is it right? So if and we know that once the anode current increases, then latching current of a SCR, the thyristor, it turns on. So in this phase control of SCR, what we are going to do is, we are going to increase the Ig such that IA it becomes greater than that of a latching current, and that is nothing but the phase control of a SCR, right? So I can also control the instant at which the thyristor it turns on by using this phase control of a SCR. So there are many ways how I can increase the Ig. The one way of increasing Ig is by using the RC circuit. That is, I need to connect the resistor and connector such a way that it increases the Ig, which in turn makes IA greater than that of a latching current. Let us see this circuit diagram. What is this RC? That is resistor capacitor phase control. The circuit diagram for this is, we have a supply voltage, let us say Vs, which is sinusoidal. The load resistor, let us say it is the RL. And thyristor is connected, which is in series with this load thyristor, which is also known as SCR. Now I need to provide the sufficient gate current such that the terminal of this SCR it can be controlled. So for that reason, so we need to use the series RC circuit, and we need to use some protection device. So let us say here I am using the diode D1, which is first protecting diode, which protects the reverse current from gate to the capacitor. Another is the diode D. So this is the circuit called as RC phase control circuit. So as we are applying the sinusoidal input it has positive half cycle, it has negative half cycle. Let us start the analysis negative half cycle. So during negative half cycle, the polarities of the supply voltage, it becomes negative upside, positive downside. So this negative is connected to the cathode of this diode. If I assume the voltage at anode as a 0, diode D2 will be the forward bias. So this will be the forward bias because anode is more positive with respect to the cathode. Cathode is connected to the negative of a supply voltage. Let us assume that anode it has 0 voltage. So 0 is greater than that of a negative. Hence I can say diode D2 is forward bias. Reason is that anode is more positive with respect to the cathode. Alright. Now let us draw the equivalent circuit for this RC phase control in negative half cycle. So we have sinusoidal input voltage Vs with negative upside, positive downside because it is negative up cycle. Then load resistance RL, SCR, then the RC circuit. Now diode D2 is forward bias, it acts as a short circuit. So this is what the short circuit, this is the variable resistor R, this is capacitor C. Okay. And here we have the diode D1. Now let us identify the state of diode. As positive is connected to the capacitor, so diode is short circuited. So this capacitor C, it starts charging and the charging path is from positive terminal to the capacitor. The current it won't go in this direction. Reason is that this SCR still it is not turned on. Now the capacitor starts charging. So this is the path for capacitor charging. This is the path for charging of a capacitor. Right? So capacitor it slowly charges from 0 to the maximum value of this input voltage. So we know that input voltage is Vs, which is nothing but Vm sin omega t. So it reaches to its maximum value with the polarities plus downside and upside minus. As this minus is connected to the anode of a diode, so this diode is open circuited. So this diode D1 is open circuited while diode D2 is short circuited. Right? This is the condition of a circuit during the negative up cycle. Also, if you observe, so positive is connected to the cathode of a SCR, negative is connected to the anode of a SCR, and the SCR is in reverse blocking state. And it is not a favorable condition to turn on the SCR. The SCR it can be turned on only when the thyristor is in forward blocking state, and which is known as favorable condition to turn on the SCR. As SCR is in not favorable condition, that is it is in reverse blocking state, I cannot apply a gate supply, hence the diode must be the open circuit, and that is achieved in this negative up cycle. Further, what it is achieved, that capacitor is charged to the maximum value Vm. So here Vm is the voltage across this capacitor. This is all about the negative up cycle. If we draw the waveforms for this, let us say this is the supply voltage Vs. Then we will draw the voltage across capacitor. Then the output voltage or the voltage across the load resistor. This is the supply voltage Vs. If we consider the two cycles of an input, the circuit behavior can be studied well by plotting this waveforms. So this is the sinusoidal input. So horizontal axis is omega t, where this Vs is nothing but Vm sin omega t. Maximum value is Vm, minimum value is minus. During positive up cycle, let us see what happens. During positive up cycle of a input, so this polarities gets reversed. The upper terminal it becomes a positive, lower terminal it becomes a negative. Anode of a SCR is connected to the positive, cathode is connected to the negative. The thyristor is said to be in forward blocking state, which is the favorable condition to apply the gate voltage now. No? So that D1 it must be the forward bias. And the voltage across this capacitor, it is applied to the gate which turn on this SCR, right? Now, as positive is connected to the cathode, diode D2 it will be an open circuit. So positive is connected to the cathode, let us assume that anode is 0. So this will be a reverse bias and we will get the open circuit here. So this is nothing but the open circuit of a diode. Now the current it starts moving from positive terminal, okay, and it moves from anode to the cathode once SCR it turns on. Now the voltage across this is minus Vm at the beginning, so it will be the minus Vm, right? So the current, it starts flowing from this resistor to capacitor, and capacitor, it starts charging again, and it starts charging from minus Vm. So it starts charging from minus Vm to somewhere. It reaches to the 0 here. Okay. Then when it reaches to the value called as Vg minimum, it is the minimum gate voltage which is required to turn on the SCR when SCR is in forward blocking state. Now SCR is in a forward blocking state, simply I need to apply the Vg so that SCR gets turned on. Now as the current, it starts moving from this RC circuit, the capacitor, it starts charging slowly from minus Vm to positive value. When it reaches to this Vg, so this diode D1, it forward bias. So diode, it becomes the forward bias and it acts as a short circuit. The SCR, it gets turned on. So when SCR, it gets turned on, right, so the capacitor, voltage across this capacitor, it is discharged through gate to cathode junction and again come back. So this is what the path for discharging a capacitor. The capacitor, it get discharged, right? So here it is the discharging of a capacitor. So it comes to the 0. Okay. Now again, when the next negative up cycle it starts first charging to the minus Vm. Again, when the next positive cycle it comes, it starts charging, so it reaches to the some value Vg. Thyristor, it gets turned on, capacitor discharges, and this cycle it repeats. This cycle is repeated. Now what happens when SCR, it gets turned on? So let us draw the Vn, that is nothing but voltage across this load resistance. When SCR is turned on, so this SCR, it acts as now short circuit and all the current, it starts flowing in this path. And the output voltage, which is equal to the input voltage. As the SCR is turned on, at this instant, the output voltage is something like this. So this is the output voltage, which is equal to the input voltage. During negative up cycle, SCR is off, hence output voltage is 0. Again during positive up cycle, so here SCR is turned on, hence you get the output voltage something like this. So this hashed portion is nothing but the nature of output voltage. Now, so this distance is known as the phase or firing angle of an SCR, which is most commonly defined by the symbol alpha. And this alpha, it can be varied. I can change these values of the alpha simply by varying this variable resistor. If I change the value of R, the charging and discharging path for the capacitor, it is varied, and I can change these values of a alpha. And this is nothing but the phase control of a SCR. I can set any value of a alpha from 0 to pi. So this is 0, this is pi. I can take any value in between 0 to pi. This is all about the silicon control rectifier, its 2 transistor model and phase control of a SCR. Thank you.